Ever wondered how machines learn? How they adapt and improve over time without being explicitly programmed? Welcome to the fascinating world of machine learning. It's a realm where algorithms empower machines to learn from data. They digest this information, make decisions, form predictions, and continually refine their knowledge. But here's the kicker. Not all machine learning systems are created equal. There's a variety of types, each with its unique approach to learning. Intrigued? Hold that thought. We're about to delve into the different types of machine learning systems. Imagine a child learning with the guidance of a teacher. This is akin to supervised learning. Now let's dive into the world of supervised learning. Here, machines learn from labeled data. What's labeled data, you ask? Well, it's data that includes both the input and the corresponding correct output. It's like having a study guide with all the answers. Let's take email spam filters as an example. They're trained on a set of emails labeled as spam or not spam. The machine learns the patterns of spam mails and applies this knowledge to filter out future spam, or consider weather predictions. They use historical weather data like temperature and humidity to predict future weather conditions. Likewise, predicting house prices would involve training a machine on a wealth of historical data such as location, size, and age of the house. So, supervised learning is all about learning with a guide, using labeled data. But what if there's no guide or labels? Now, picture a child exploring and learning on their own. This resembles unsupervised learning. Unsupervised learning is a type of machine learning where computers learn without any supervision. Rather than being spoon-fed labeled data, the machines are given a pile of unlabeled data and are tasked with finding hidden patterns and structures within it. It's like handing a child a box of random Lego bricks and letting them figure out what they can build. Let's pepper this with some real-world examples. Consider customer segmentation in marketing. Companies often use unsupervised learning to group customers into different segments based on their purchasing habits, preferences, and behaviors. This helps businesses tailor their strategies and maximize customer satisfaction. Or take network traffic analysis. Unsupervised learning algorithms can help detect unusual patterns or anomalies in network traffic, providing an early warning system for potential cyber attacks. So that's unsupervised learning, where machines learn to identify patterns without any guidance. But what if the machine could learn through trial and error? Think of a toddler learning to walk. They stumble, they fall, but they get up and try again. This is the essence of reinforcement learning. Reinforcement learning is a type of machine learning where an agent learns to make decisions by interacting with its environment. It's like a game of hot and cold. The machine or agent takes an action, and the environment provides feedback in the form of rewards or penalties. For example, consider self-driving cars. These vehicles are continuously making decisions based on their surroundings. When the car makes a safe decision like avoiding a pedestrian, it receives a positive reward. On the other hand, unsafe decisions like veering into oncoming traffic would result in a penalty. Another example is game-playing AI like AlphaGo, designed by Google's DeepMind. AlphaGo uses reinforcement learning to master the game of Go, learning from each move it makes, whether it wins or loses. Reinforcement learning, a way for machines to learn from their mistakes and rewards. But how do all these compare? So, we've taken a journey through the world of machine learning, exploring its different types. We've seen how supervised learning works like a teacher-student relationship, with machines learning from labeled data and then applying these learned patterns to new, unseen data. It's a powerful tool for tasks such as image recognition, speech-to-text, and predicting future trends. On the other hand, unsupervised learning is like an explorer, seeking out hidden patterns and structures within unlabeled data. It's a great fit for tasks like market segmentation, anomaly detection, and understanding complex data sets. Yet it requires a lot of data and can sometimes lead to overfitting. Then we've got reinforcement learning, the trial and error specialist. This learning type allows machines to interact with their environment, learning from both successes and failures. It's a key player in areas like game playing, robotics, and navigation. However, it can be computationally expensive and time-consuming. Each of these learning types has its strengths and weaknesses, and they all shine in different applications. They're not competitors, but rather complementary tools in the vast toolbox of machine learning. They work together, each contributing its unique approach to help machines understand, learn, and adapt. With machine learning, we're teaching machines to think, learn, and even make decisions just like us. Who knows what they might learn next?